Hi, this is Jenna Bakandi, and today we're going to be reviewing areas and perimeters. Area and perimeters, section 10.2. In this section, we're going to review a little bit about pegboards, different ways you could look at parallelograms, area and perimeter for rectangles, circles, etc., and a whole lot more. First, I'd like to show some examples of how we can use other shapes to relate to other units in size and shape. As you can see, I took a lead from the video that we watched for this section, and I really loved how the woman showed us how we could use different types of shapes to show children that different shapes can go into others and units can also be related into different sizes. So if we first look at the square, we see that we can actually try to fit these two triangles inside of the square. And if you put these two triangles together, you see that you could also make a square. So if you put these on top of it, you obviously see that two triangles can make the same size of the square. So two units go into the one square. Then if we take this bigger triangle, we can take these two units, because obviously the square will not fit. These two smaller triangles, we could try to shift them around until we get the correct shape. And we see that the two triangles, or the two units, go into the one triangle. Then if we take our last shape, it's the largest triangle. Now we could take these smallest units, the ones, and try to see how that can go into it. You can see that we have two here, but even if we place another one here, we would have to have another one, it looks like, too. So you could also just do that, and you'll see 1, 2, 3 units, and then if you turn this upside down, if you had enough, you could actually make 4. But in this case, we only have 2 of the smaller units. But remember earlier, these 2 went into the smaller triangle, but they also went into the square. So if we take the square, which we already know is 2 smaller units, the triangles, and shift it, we have 1, 2, 3, 4 units in the one big triangle. And that's just an easy way of how to explain it to maybe younger children that don't understand and they can't exactly comprehend it. I've really enjoyed this presentation this week. Another great display or example we were shown this week was a pegboard, or also called a geoboard. I used to play with these when I was a little kid all the time, so I'm very familiar with them, and I'm actually back ordered on an Amazon order for them right now. So if you'll see, I have drawn us a 4x5 square for our pegboard or our geoboard, and just to show a quick example, we could just draw up 2, 4 across, 2 down, 4 across, and we have a simple rectangle. To find the perimeter or the area, simply all you have to do is 1, 2, 3. That's 2 units right there. 1, 2, and then 1, 2, 3. That's 3 units across, 4 dots, but 3 units across. So this would be 2 by 3, which would equal 6. So we have 6 units in the side of this rectangle. Now, if we were to change this by simply going up 1 over and 1 down, we would have 1, 2, 3, 4 units times 1, 2, 3. And 4 times 3 would be 12. So I think this is a really neat way of how to show kids. You could separate stuff. And also, if you take another rubber band, which I can't show right here, but I can draw, you could separate it. So you can see that it goes into triangles or smaller units. You could even go further than that if you want. This is a great example how to show younger kids, like I was saying. Here I have another version of the pegboard or geoboard, and I actually just wanted to show you a drawn parallelogram because I thought this would be another great example. As you can see, I already have a parallelogram. It's 2 units down, 2 across. But this is a great way to show children how you could also fit those smaller units like the triangles that we looked at on our first page. So if you take another rubber band, you could actually cross off these sections, and there you have it. You actually have two triangles and then a smaller rectangle in the back, or in the middle, and that's actually the parallelogram. Or on the offhand, you can take away one side of the parallelogram and add it to the other side, and you have a square. Okay, here I have a set of smaller single units. If we add these units together, we actually have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's just focus on this first row for now. So if we just add these 6 units together, it's 6 units. So this would be 6 single square area units. Now to find perimeter. Well, remember, we have 6 units. So we'll have 6 units on this side, 6 units across on this side for our length, 1 on the side and 1 on the side. So that would be 14. So you'd have 14 units for perimeter. Now let's see if we add some units. So here we'll just simply add another aisle 6 to the original 6. So now we have a perimeter or an area of 12 square units. Okay, so this is 12 units for the area. Now for the perimeter, again, it'd be 6 on one side, 6 on the other, 2 on this side, 2 on that side. So that would actually be 16 instead of 14 for the perimeter. Now if we switch up these units, we could actually see that we have the same amount of units. And notice that even though we've rearranged it and we have the same area still, we actually have different perimeters, because here we would have 4 going across, 4 across, 3 on the side, 3 on the side. So this would actually be 8 plus 6, which would be 14. So we have a different perimeter. Okay, now let's review going over the perimeter and areas of circles. 2 of the most important formulas that we're going to go over are actually going to be circumference and area. First, we're going to go over the circumference of a circle. So for the circumference of a circle, it's going to be the circumference over the diameter equals pi. So that's going to be the circumference divided by the diameter, which equals pi, or 3.14. Approximately 3.14, which means that it's actually an improper number, or irrational number, I apologize. So that means that we can't actually use that. So in these terms, we'll actually go to this other formula, which is circumference equals pi times diameter. Or if you don't have the full diameter, in this case, I give you 2 different examples, you could actually do the circumference equals 2 times pi times the radius of the circle. So for this example, I've actually got 2 different ones. This includes a circle with the radius of 4 centimeters. So if we use our formula, we're actually going to get, our problem is going to be C equals 2 times pi times r, which is going to be 2 times pi, or 3.14 approximately, times the radius of 4 centimeters, which is going to come out to be 25.13, or 8 pi. And I'll work that out for you. It's going to be 2 times pi times 4 equals 8 pi, or if you use the decimal number, 25.13, round up to the 2 decimal places. All right, now for the second problem that I have drawn as an example, where you have the full diameter. So we could actually use our first formula, which is circumference equals pi times diameter. So if we do pi times diameter, it's going to be 8, which would equal 8 pi, or if we use the decimal number, 25.13. And you could tell that this is the same problem because 4 is half of 8, and the radius is half of whatever the diameter is. So this is actually the same problem, the same answer. So we've actually double checked our answer, and we know that we have actually done the formula correct. Finally, let's review the area of a circle. Area equals pi times the radius squared. So in any case that you have the diameter, you could already know that you're going to split the diameter in half and do the radius times squared. So let's say that you have 16, as our diameter, you know that half of that is going to be 8. So that's what you would use for this formula. If you ever get the diameter, cut it in half. That's what you'll use for that. So in this case, 8 is our radius. So we already know our diameter would actually be 16 because the diameter is twice the amount of the radius. But in this case, pi times 8 squared, if we do our math, would actually be, let's write down that formula. It would be pi times 8 squared equals either 64 pi, because 8 squared is 64, or if we do our decimal place, it's actually 201.06 continued. And that's how you find the area of a circle. Elfin, that's it for this section. Thank you so much for being a part of my short review of section 10.2 on areas and perimeters. Have a wonderful night.